All right, hello everyone. Let's start the class. All right, so uh, for the last 2 weeks, right, from today, we'll just talk about our last chapter, which is data mining. All right, so actually, in our real life, we keep talking about the data mining, right? So actually, data mining has already become a very um, fashion word, right? So what is the data mining? So actually data mining is to describe or not describe, is to dig the useful information from a large data set. Right, just like what you did in the project two, you are doing data mining, right? So actually you have a whole data set, right, about describing the house price. Actually you have the raw facts of the house for each house, right? So for each house you have the overall quality, you have number of floors, number of bedrooms, number of bathrooms. So actually they are just listing all the information about this house. Your job is to find the useful information from the whole raw data. Right, and then this process, it would be just called the data mining. So actually data mining is not a very top word that some professional people can only the professional people can do this. Right, so actually what you have already did in this whole semester, you are doing the data mining, right? So about how you make the hypothesis test, how you make compute the confidence interval, right? And then how you get the regression, how you make the predictions. All of these processes, actually, you are doing the data mining. But before we go through more details about data mining, I think it is a good time to talk about the whole data mining process. So actually, um, we say the data analytics, this job is we call it is the sexiest job in the 21st century, right? So actually almost every field will need uh, the data analytics, but there is also one kind of famous phrase about statistics we call the liar, damned liar, and statistics. Right, so kind of everyone thinks that, not everyone, right? Not except me, right? So not actually someone will think that we are playing with the numbers that give different conclusion based on different goals, right? So if I want to support someone's opinion, then I can play with the numbers and then I can give a lot of proofs, and then okay, I can strongly support this person's idea, even though this person's idea is very weak. I can play with the numbers to give the proofs, right? And even though um, kind of this sentence is kind of to um, describe the power of the numbers, especially for statistics, right? They can just play with the numbers and support my opinion and even to against others' opinion, right? Just to give different conclusions. But actually, this is not true. Of course, this is not true, right? So statistics, of course, statistics is a science, right? Science doesn't tell lies. So why someone or some people will think about this way, actually, um, it is because how you understand the data, how you play with the data, right? Whether you analyze the data in a correct way. So every very small thing will make you a totally different conclusion, right? So just like um, when we talk about the house price, right? We keep talking about house price. Actually, from the first step, when you collect the data, you may have different conclusion at the end. So from the first step, you need to make sure your sample is representative. Everyone has different samples, right? So actually from the first beginning, you actually have the chance to give a different conclusion. So if you have a different sample, you may have different conclusion, even though you have the same sample. You may analyze this sample, you may analyze this data set in a different way. For example, some of you choose to analyze the whole or all the houses I provided in the sample. Some of you choose to analyze just one kind of house, right? Then of course, you may have different conclusions, right? And then even though you correctly use the data set, you may have different ways to analyze the data. Some of you use the forward method. The other way is backward method. Some of you just think about which variable I want, right? So actually different people have different ways to analyze the data. Of course, your conclusion will be different. Your models will be different, right? And then even if everyone used the same method, even if everyone has the same result, same regression equation, you have the chance to interpret the results incorrectly. For example, in our simple regression and multiple regression, right? So when we just make the regression with the number of bedrooms, the coefficient of the number of bedroom is positive. That means you have the larger number of bedrooms, the house price will increase. This makes sense, right? But when we add the living area into our model, the coefficient of the number of bedrooms change to negative. Then how you interpret this coefficient? If you don't understand statistics well, you don't understand this part well, you may think that, okay, when the number of bedrooms increase, the house price will decrease. Is that the truth? If you interpret like this, someone will think, okay, you are a liar. Because what? Because based on the simple regression, you said the more bedroom, the house price will increase. But now you tell me that the number of bedroom increase, the house price will decrease. Should I believe you? Of course not, because you didn't interpret your results correctly. Then you become a liar, not the statistics is a liar. So actually you didn't do it in the correct way. You didn't interpret your result in the correct way. So actually we say when the living area is fixed, then the number of bedrooms increase by 1, the house price will decrease. So actually when from the beginning until you make the interpretation or you make the conclusion, you have so many things that even though you did it correctly, you may have different conclusion. But of course, if you make any mistake, your conclusion will be totally different. Right? Even though you did everything right, for example, in the hypothesis test, your p-value, for example, your p-value is, let's say, 0.03. Everything is right, right, from the beginning. Your sample is representative. You did it right in when you compute this hypothesis test, you got the p-value is 0.03. But if I set my alpha is 0.05, what will be your conclusion? Reject the null hypothesis, right? Because your p-value is less than alpha. But the other way, if you set alpha is 0.01, you fail to reject the null hypothesis, right? So that means you have a totally different, actually opposite conclusion just based on different level of alpha, right? Then actually the point to make different conclusion, actually you always need to state your alpha level, because based on different alpha level you have different conclusion. But if you state your alpha correctly, then you know how accurate is your hypothesis test. We say when alpha is small, which is 0.01, then my hypothesis test will be more accurate, right? So then if you reject the null hypothesis, that means the null hypothesis will be about 99% not right. right? Then you rejected the null hypothesis. So of course your hypothesis test will be more accurate. But they depend on different situation. My hypothesis test may not require to be that accurate. Just to keep it 0.05 will be okay. Then you will have another conclusion, right? So actually for statistics, um, um, we don't say play with the numbers, actually kind of play with the rules. So you have different standards, you have different requirements. I can provide different conclusions, but actually the whole process is not a lie. It's just that your requirements will be different. Your standards will be different. Even though you did everything right, at the end you may have different interpretations, right? So actually, um, I don't think there is any technical difficulty for the data mining. Actually, the most difficult part for the data mining is you can provide the correct interpretations, the correct conclusion. You can analyze the right um, data, right? You can correctly use the data. If you have any outliers, you remove the outliers, right? So that everything will not affect your conclusion. So actually all of the side things are actually not the techniques itself, because every software can generate the result out. But actually the point is how you use the data, how you analyze the data, how you understand your results. That will be the point, the biggest point in data mining. All right, and here I just provided 3 videos, right? So actually, if you have time, just watch these 3 videos will help you generate a bigger idea about data mining, right? So the first one is actually um, not a video, it's just a article, right, about why we say big data is not truth. Why, even though we have the big data after the data mining, why we may not telling the truth. It covers a lot of aspects that you may make the mistakes. All right, so actually for this course, I just focus more on how you understand things, how you make the right interpretation so that you do not have the right, or you do not have the wrong decision, especially in our business field. It is very, very important that you have the right conclusion. Otherwise, you will lose millions of dollars. You may make the wrong decision that you may make a company just fail. All right, just based on just one decision, you may just make everything destroyed. All right, so um, these two are the kind of um, the videos, right, about how the big data and big data mining improved words, well, improve the word, right? So actually, when I don't want you to more focus on the calculating the numbers itself, calculating the every test statistics or something, I will more focus on how you understand it. Right? I will, of course, that is why I didn't ask you to remember any formulas, right? Because you can always find the formulas from the Google search, right? But how you understand it, right? Why you use this formula. After you calculate it, what kind of information you can get, right? Once I have a confidence interval with 2 numbers, what does these 2 numbers mean, right? So you cannot just say, okay, this is my confidence interval. Then what does that mean, right? If you are the manager, someone gave you this confidence interval. Can you understand this confidence interval? If someone give you a wrong interpretation about this confidence interval, about this coefficient, can you identify this is not right when you make the decision? This is very, very important, right? So that is also why almost all the majors require to take the stats courses in recently, right? So actually, this is very, very important in every field, especially in our business field, right? It doesn't matter you are just analyze the data or you even don't need to analyze the data. When you read the report, you always need to know what does that mean, right? So kind of just blah, blah, blah. All right, so let's talk about our data mining. All right, so we say data mining is to deal with the big data, right? So what is the big data? So this big data doesn't mean that we have a large data, right? So for example, if we have 10,000 of observations, is that a big data? Um, Actually, it is not a true big data. So actually this big, actually this means it describes the raw facts of the word. So actually, what does that mean? For example, if I want to describe the house, do you just want to describe the house price? Of course not, right? So whenever we have the house, how you can describe the raw facts of this house, you actually need to describe is year of build, number of bathroom, number of bedrooms, right? You also need to talk about the living area, all aspects. Even though this data set just have maybe 30 houses, but these 30 houses are, you have the raw facts of these 30 houses, then this data set is also called a big data because it describes the raw fact of this house. All right, and then our job is to dig in the useful information from this big data. We want to discard some unuseful information. We want to just find the useful information from all of these predictors. And then in our project, we just want to focus on 5 to 6 useful information, useful predictors, so that we can make the predictions. All right, then this process will be called data mining. We just find the useful information from all aspects of this house. All right, and then we say, we talk about big data, right? But actually big data can be divided into different types, right? So here we just gave some introduction about some basic concepts in data mining, right? So first about the big data. So where does these big data come from? We say when you purchase something online, it doesn't matter what you purchase. Actually, you will always generate these records. The length of time on this site, right? The items you viewed, items you purchased, what size, what color, right? And then the methods of your purchase, the promotion, whether you use any promotion, any coupons, right? And then what is your credit card information, the credit verification, and then your shipping information. All of these information will be saved as one record. And then these information for one observation, but for example, for Amazon, right, you have millions of transactions per day, then you would generate a transactional data for every customer, right? And then this will be a very powerful data for any company. So actually, you can find that, for example, if you searched calculators in Amazon, next time they will push you more, give you more information about other calculators. So how they can do that? They just have real time analyze about your own records, your own transaction records. So actually the whole process is very powerful. All right, so we say for this kind of data, right? When you purchase anything, it doesn't matter you purchase anything online or in the real stores, right? For example, if you purchase anything from Kroger will have its own transactional data. For example, what you purchased, right? And how much money you spent, and you paid with cash or with credit card, your credit card information, right? Even though, for example, uh, you purchase the food or other categories, something like that, right? So all of these will be saved as transactional data, and they will be analyzed by some specific companies. All right, so why we want to save these transactional data? So actually we want to improve our sales. We want to learn about our customers, right? I want to know some deep, deep facts about their transactions, right? So actually we always want to find the solutions to improve the world, maybe not improve the world, we want to improve our sales, right? So actually this kind of data we'll call the transactional data. The other kind of data is, for example, we own a house. In the end, it doesn't matter your house is in, you want to sell your market or you do not want to sell your market, sell your house. Your house information is already there, right? So you may have the house, the estimated price of this house in market, right? You have the living area of this house. You have the number of bedrooms, location, number of bathrooms, overall condition, all of these predictors. But actually, even though you do not want to sell your house information is all online. They have the records, right? And then we say, since this house is not for sale, it's not for transaction, you didn't sell this house to anyone else. This house is about your own house. Then we call it is the individual data. It is about yourself, right? Then we call it is the individual data, or we call it is the demographic data. All right, another example about individual data is whenever you want to, whenever you report an accident to police or your insurance company, right? You always generate the following records, right? Your name, your driver's license information, right? The time of the accident, the location of the accident, insurance company, ID number, right? So actually you provided all of these information, and then of course your information will be recorded as another kind of data. But this kind of data is not for transaction, right? It's not for sale. It is kind of not your own information to describe yourself. But actually this is another kind of data. We call it is kind of, I don't know why this book call it is the regional data, but actually in statistics we call it is just the census data. So actually it is for the government. It is to not to sell something or to improve your sales or something like that. It is kind of keep a record about the whole, let's say, about the whole process or the whole thing. All right, so then we say the types of the big data will be these three kinds, right? The first kind is obtained during the transactions, when you buy something, when you sell something, right? Then you have the transactional data. The other one is about your individual, about yourself. It doesn't matter it is about yourself or the house itself or anything itself, just to describe something, to describe itself, right? Then it is called the individual data or demographic data, right? Just like if you have a Kroger card, right? You will have your personal information in that card when you apply that card, right? So you have your name on it, date of birth on it, right? Your location on it, right? And then what offers, what promotions you used, right? What coupons you used, right? So actually all of this information will be saved in your Kroger card, and then that will be your individual data. All right, okay, and then another kind of data is the census data. For example, when the government generates a map for the whole United States, right, about the population, about, for example, our accident results, right, about, let's say, uh, the birth rate, right? So all of these are not about yourself, not about the transactions. Then it will be about our, we call the regional data or the census data. All right, so actually all of these data have their special components to analyze all kinds of these data, right? So they may just focus on doing this kind of things to dig the useful information from all kinds of data sets. All right, and then since we are already talked about what are the big data, right? Where does these data come from? Let's talk about data mining. What is data mining? We say what we learned within this semester, we are doing the data mining. All right, so actually remember what you learned in ISA 125 or before this course. We say once we have the raw data, what is our first step? Is that we just go straightforward, go to the job and then build the model directly? Of course not, right? So actually the first job for us, once we have a raw data, we want to learn about each predictor. We want to know something about each variable, right? So actually we want to describe each variable or describe the whole phenomena, right? So for example, I want to know what is the percentage of female in this class, right? So actually you are just describe the whole thing, right? Describe the whole class. We say 45% of this class of this section is female. Then we are describing this class, right? So actually we are doing descriptive analytics, right? So actually in the last class, in the last course, ISA 125, for example, we are calculating the mean of this variable. We are calculating or find the median of this variable. We are calculating the standard deviation of this variable. We generate the histogram of this variable, right? So all of these ones, we are doing the descriptive analytics. Again, descriptive analytics is not data mining, right? We are just to make a summary about what we have. We didn't dig anything. We didn't find any useful information from this data set. We just describe it. Whatever you have, I just give a summary. Right. Then we are doing the descriptive analytics. But after this step, we get some information. We get the mean of it. We get the standard deviation of it. And then with this information, we can do the data mining next step. For example, in the regression, how you calculate these coefficients. Actually, all of these coefficients are calculated with the mean of each variable, standard deviation of each variable. But actually, we just use the software to save the steps. But actually, the insight is to use these summary statistics to calculate each coefficient. right? For example, how you made the hypothesis test. You are using the mean of this variable. You are using the standard deviation of each variable to make this hypothesis test, right? So actually, the data mining is based on the information you got from the descriptive analytics, right? Based on the summary, based on the information from each variable, you can dig the useful information out, right? And then you may choose some useful variables, or you can make the hypothesis test or confidence interval based on these informations, right? Then we call this process is our data mining process. All right, so once we get or we go through the data mining process, we will get some knowledge about the whole phenomena. We get some knowledge about the whole house market. All right, and then based on the whole knowledge about the whole thing, we can make our decision. And then this is another field, which is our business marketing analytics, right? You may learn this, how to make the decision based on our results in other courses, right? Based on your own fields, right? So actually it's based on your own understanding, right? So actually what we focus on is we use the information, dig some useful information out, and then get some knowledge about the whole phenomena, about the whole world, right? That will be our data mining, right? So again, remember, data mining is not making summary about the data. We are using the summary of the data to make some result, get some results, and make some conclusions, right? So especially since data mining is so fashion words in our recent time, right? So when you read the newspapers, someone say, okay, we used a lot of data mining methods, techniques that we find out in our supermarket. Let's say more and more people um, want to buy the organics products. Is that is that data mining techniques? Of course not, right? So you just summarize the proportion of people who buy the organics products keep increasing for each year, right? So that means you are summarizing the data, right? And sometimes when you read some reports from any company, right, you may see that we used a lot of data mining techniques, find out that um, they, uh, let's say, the, the mean cell, right, for example, the mean cell, um, uh, that would be too simple. Let's say the percentage of the employees age uh, is about is above uh, 30 years old, something like that, right? So actually all of these kinds of sentence is not right, right? They are not using the data mining techniques. They are just summarize the data. They just answer some descriptive answers, descriptive questions. Right. So actually data mining actually is the most important step when you have a raw data until you want to make the decision make. Right. So actually this is the most important steps. Right. So here I just state two examples. Right. So first example, just imagine that if you want to send the offers out, right? But if you just send the offers or coupons to the people who are interested or who will use these coupons, then you will save a lot of time, you will save a lot of money on this, on the advisings, right? So actually, when you know who will be interested in this offer or coupon based on your data analysis or based on your data mining, you will save a lot of time and money. All right. And another thing is, uh, when you just buy the target marketing, right, you will be very um, easily to increase the return on the campaign, right? Because what? Because you have your focus. You know who will be interested in your project, right? Who will use this coupon, and then you just send out the coupon. Of course, the percentage of the coupon use will be increased, and then you also save your money who to the people who even don't care, never purchased this product, right? So you even don't, you just save the time, save the paper, even save the energy to send out all the advisements to the people who don't care about this. All right, okay, and then for actually for this paragraph, kind of a kind of summary about what we talked about, right? So actually we say we want to generate a model from the transactional data or the demographic data to help the companies to point their most likely customers, right? And also for this part, I just don't want to talk about this, right? So remember, summarizing the large data is not data mining, right? So when you look for jobs, right, if they ask about the techniques for data mining, right, when you get the interview, right, don't talk about anything about I can summarize the data, right? I am able to get the mean standard deviations, right? So don't do that, right? Data mining means regression, right? Hypothesis test, confidence intervals, right? So actually you are using useful information to make the predictions or for other uses, right? So remember, summarize the large data is not data mining, right? So then we say the next, I just want to show you an example. Right, so here this is a data set, right, which is the supermarket is offering a new line of organic products and want to determine which customers are likely to purchase these products or study about whether they will purchase the organic products. All right, and then um, if you go to our module 6, the first data set will be our organics data set. Right. So actually in this data set, you have the whole story about each transaction. So of course that will be a big data. Right. So then you have the ID number, which is, for example, the ID number for this market card or something like that, right? And you have all of these variables. And then here I have a detailed information for these 13 variables. All right. And then we say first ID. Should ID be analyzed? It doesn't have any useful information. They are just ordered, right? So that means ID cannot be any of the variables that we want to include in our analysis, right? So it cannot be response variable. It cannot be any explanatory variable. It's just the identifications, right? And then next, we have the affluence grade, their age, right? And then you have the type of residential neighborhood. And I have another variable which is called the neighborhood group. you can find that they are repeated, right? So then in this case, when we have the big data, the first step is analyze or look at these variables to see whether you have repeated information. For example, in your house price, the house price project 2, right? So kind of the first floor not accurate example, right? So actually the first floor area and sorry. All right, the first floor area and the second floor area, they are kind of related, although they are not the same, but actually in our real analysis, we will avoid to include both of these two because they are very correlated. Right, but in this data set, actually, we can even delete these two. We can delete one of them because what? Because they are kind of the same thing, right? Then we say in the model row, we just consider the first one is rejected. That means I do not want to input this variable into our analysis. This variable can be deleted. All right, we just keep one of them. Right? And then we have other variables, for example, the gender, which is the categorical variable. We have the region, which is also categorical variable. We have, for example, the total amount spent will be the continuous variable, right? So we have all kinds of variables as what as our explanatory variables. Right, so that we have totally 9 explanatory variables. We want to study about the organics, whether they purchase any organics products, right? So actually, I can collect my response variable with 2 ways. The first way is I just care about whether they purchased any organic product. Then I can just collect it with binary responses. That means as a categorical variable, whether they purchased it, right? So that means will be yes or no. I can record it as 1 or 0, but this one will be the categorical variable, right? Or I can collect our response variable with a continuous random variable as number of organics products they purchased. 1, 2, 3, 4, or something like that, right? So then it will be continuous random variable, right? Depending on what kind or what information you use, what kind of analysis what kind of questions you want to answer. All right, and then here for different kind of questions, right, we have different kind of analytics, right? We call one is descriptive analytics, another one is called the predictive analytics, right? So remember we say when we analyze the data, once we have the raw data, the first problem or first step is to have the descriptive analytics, right? We want to describe it. And then what kind of question will be about this step? We say if we ask what is the proportion of female with 50 years or older who purchased organic products from this store? Then it's just to ask you to summarize the proportion with this data set, right? So actually what you do, you just focus on this data set, right? And then we focus on the female, and then what else? The age, right? 80 years, 50 years or older, right? And then we just look at whether they will purchase organic products, right? So actually we just summarize the proportion of these two female and 50 years and older who purchased the organic products. So actually we didn't do anything, or we didn't let's say we didn't want to make any predictions. We just based on the raw data, we have some conclusion, right? And then we call this kind of analytics, we call it is the descriptive analytics. Another kind of question, say, make a prediction on the sales of organic products for a target group of customers. So for example, I want to make a prediction on the sales of organic products for the female 50 years and older. Then that means you do not have the information from what you have in the raw data. What you need to do is to generate a model so that you can make the prediction for the whole group, right? And then the other kind of question is, which customers from our larger database are most likely to purchase the organic products? Right. So then we have some deep question based on this raw data, right? Then we will need the predictive analytics. Actually, this process is the data mining process. All right. Okay. And then we say, based on different questions, right? Even though you are making the predictive analytics, actually these two questions are focusing on different things, right? The first question is focusing on the making the predictions. The other question is focusing on the groups. Um, what kind of customer will purchase the organic products, right? So then based on different kind of questions, we have different ways or different modelings, right? The first one we call it is the explanatory modeling. So what is explanatory modeling, right? So actually from the name, we say we want to explain something. We want to know the relationship between the predictor and the response variable. Right. For example, I want to know the relationship between X and Y. This is their relationship. I will more focus on what is their relationship. That means at the same time, you need to describe what does this 2 mean? What does this 3 mean in this equation? Then these 2 and 3 tells you the relationship between X and Y. We say when X increase by 1, Y will increase by 3. This is their relationship, right? So that means based on this relationship, I can kind of get an idea about when X change by some amount, Y will change by what amount, right? So for this kind of modeling, we call the explanatory modeling. We say we generate a relationship between the predictors and the response so that we can interpret the coefficients. We can get some hypothesis test or goodness of fit test so that we can tell the relationship between the predictors and the responses. We care about what is their relationship. All right. And another kind of modeling we call, or to answer another kind of question, we more focus on predictions. Right? We don't care about what is the relationship between the predictors and the response. I don't care whether I have this equation. I just want to make the predictions. I have a house. I just want to make a prediction about the house price of my house. I don't care what will change if my house change from 1 bedroom to 2 bedroom, what will change to my house price. I just want to make the prediction for my house itself. I don't want to make any change. Right? I will more focus on the predictions. then actually there are many ways that you even don't need to produce or get this equation. You don't need to set up this model. There are many other ways to just focus on the predictions. All right, just like in our course, right, for this week, we'll focus on the decision tree. So actually, decision tree is also based on our regression. But the point is, you don't need to generate the model by yourself. The software or the jump, right, can provide a method, right? So the inside is still the modeling, but now it will give you another kind of straightforward picture so that you don't need to go through this process. You can just make the predictions directly, right? So we will talk about this later. Right. So based on different goals of your analysis, if you want to tell about the relationship between the predictors and response, I want to know when X changed, what will happen to the Y. Right. Then we will have the explanatory modeling. The other kind is I don't care when X changed, how Y will change. I just care about the predictions. Right, then you will have the predictive modeling. All right, and then we say for the previous chapters, right? So we have already talked about the explanatory modeling. So once we have the equation, you know when X changes, how the Y will change, right? So then next, I just want to focus on the predictive modeling. Right, so we say predictive modeling. We just focus on the predictions. I want to have an accurate prediction for my observation, right? And then we say for predicting performance, actually the inside of the process is still using the regression, right? The idea is still using the regression. We just have a straightforward picture to tell you directly what will be your predictions. So actually, we still use these two sets. Remember, once we have the sample, we need to divide our sample into two sets. The first one is called the training set, right? Normally it will be larger than the validation set, right? So the training set is to generate our model or generate our decision tree, right? And then validation set is to validate our model to check whether this model can provide the accurate predictions. All right, okay. And then we say we can talk about this later, but we say for the training data and validation data, right? So the jump can always produce these two kinds of data. Let's delete this column. Right, so for example, still with this house price data set, right? How I can divide this whole data set into two sets, the training set and the validation set, right? So actually we can go to analyze, right? And then there is one option called the predictive modeling, right? So within this option, you see many methods. Right, so all of these methods are the predictive modeling methods. So actually they just focus on the predictions. They will not provide you any relationship, for example, give you an equation between the X and Y. So actually they are just directly give you the predictions based on the analysis. Right, so here we'll just focus on this partition. Right, so this method is to build a decision tree to predict a response. We will talk about maybe in next 5 minutes, right? But here I want to talk about there is one option called the make the validation column. All right, if I choose that and then click OK because we do not have any specific requirements, all right, just click OK, and then there will be a default screen. Tell you that the default is 75% is the training set, 25% is the validation set, and here there is another set called the test set. Right, so actually don't get confused. The test set is not the same with the validation set. They are different things. Right, test set is another set, the third sample. Right, so normally we just set the training set proportion and validation set proportion. Normally we just set the training set to be larger and validation set to be smaller. All right, and then we say we can always change our proportion. So if I want 80% as my training set, then I can say 0.80. But at the same time, you need to change your validation set to be 0.2 so that you have the whole data set. All right, and then click go. Then you will have one more column, right? So some of them will be randomly assigned into validation set, and then some of them will be randomly assigned into the training set. And then you can filter the data so that you can just focus on your training data to generate the model, and then focus on the validation set to validate your model. All right, and then we say as long as you understand um, the the idea will be okay for our course. All right, and then if we just focus on the predicting the individual observations. For example, I just want to make the prediction about my house. I don't want to make any change about my house. I don't care about if I change my house from 1 bedroom to 2 bedrooms, what will happen to the house price. That is not the one I care about. I just want to make the prediction about my house. My house has 3 bedrooms, 2 bathrooms, and 1 fireplace. The living area is blah blah blah. All right, and then I just want to make the predictions. Right, then there is one very convenient way to make the predictions by the decision tree. Right, so we keep talking about this decision tree. So what is a decision tree? Let's talk about this example first. All right, so this example is still about the housing data, right? Since we are familiar with this part, right? So just to focus on this housing data. We have another data set, right? So which is the second data set in this module, right? So you can play with that. All right, and then we say for this data set, again, for each house, we have all of these different variables about this house. So of course, this is a big data, right? And then we say to summarize these variables, right? We just give a introduction about these variables. We say the first variable we have in this data set is the total value. That means the total accessed value for this property in thousands of United States dollars. All right, so this is the first variable. The second variable is called the tax. Right, so that will be the tax of this house. Is that just a repeat information with the total value? Yes, right? So actually the tax is calculated from the total value, just multiply by the tax rate, right? So actually they are the same thing. So they provided the same information. So then, of course, the tax will not be included in our analysis. And then next, for example, the total lot size, the property, the year built, the gross area, right? The total living area, the total number of bedrooms, bathrooms, half bath, kitchen, fireplaces, and so on. All right, all of these variables can be considered as the explanatory variable. All right, and then once we learn something about this data set, we want to generate a decision tree. Right, let's generate a decision tree. All right, let's generate a simple one. We say we can go to analyze. All right, since we just focus on the predictions, then we go to the predictive modeling. All right, and then choose the option for the partition. All right, we'll practice this in the next class, so you don't need to worry about the whole process. All right, and then of course the total value will be our Y response. All right, and then to be simple, we just focus on two of these variables. Let's say I care about the gross area and the number of floors. I just use these two as my predictors. When I click OK, this is the default output. So what does that mean? What does this picture mean? So actually, it just plots all the observations of their house prices. All right, and now my job, or the software's job, Jump's job, is to divide all of these houses into different groups until for each group they have very pure group of houses. So in this pure group, they have similar characteristics, so that once I have this kind of house, I can directly use this subgroup to make the predictions. Right, so for example, if I split the whole house, all of these houses, I will have the first step, or we call it the first branch of this decision tree. All right, so that means what? That means all of these houses, which is 5,802 houses, are divided into two subgroups based on what? Based on the gross area. Right? So the jump divide the whole or all of these houses into two subgroups, right? They find that there is a very significant difference between the houses with gross area less than 3667 and gross area larger equals to 3667. There is a big or significant difference between these two groups, and then Jump can create these two branches, create these two subgroups, divide all of the houses into two subgroups. That means what? That means if my house is, for example, 4,000 square feet, that means your house will belong to this subgroup. All right, so how many houses belongs to this house group? 926 of them. Right, and then the mean of this subgroup, the mean house price of this subgroup is 542 and 542.038 in thousands of dollars. All right, so that will be the mean house price of this subgroup. All right, if you think this subgroup is not enough, right, it's just a one step of split, we can keep splitting it. One more step, right? So now after we split all of the houses into these subgroups, they figure out that there is a big or significant difference in this subgroup, that this subgroup can be divided into two more subgroups. That means within this group, less than 2595 and larger equals to 2595, they have significant difference, so that they can be divided into two subgroups. Right, so now if my house is 2,000 square feet, That means from the beginning, right, a 2,000 square feet, that means it belongs to this subgroup, right? And then within this subgroup, which subgroup you belongs to equals to 2,000 square feet. So that will be less than 2,595. So will be belongs to this subgroup. And then you can use the mean for this subgroup houses price as your prediction of your house, right? If you think this is not enough, keep splitting, right? So if you keep splitting, okay, they jump also find that in the next significant difference happens within this group. All right, so that means there is a significant difference between the houses less than 2 floors and larger equals to 2 floors. They have significant difference in the house price within this group. So that means what? That means if I have a house equals to 2,000 square feet gross area and with 2 floors, so which group it belongs to? First, we need to read the decision tree from the top to the bottom, right? So 2,000 square feet, that will be less than 3,667, right? So within this subgroup, it belongs to less than 2,595, right? Within this subgroup, it has 2 floors that will be larger equals to 2 floors. That will be the mean house price will be 359 thousands of dollars. All right, and then if you think this is not enough, keep splitting, keep splitting, keep splitting. You can keep doing this until you think you get a more and more accurate result. They can be divided into more and more and more and more subgroups until you have a big tree. Once you have a big tree, that means for each subgroup, the houses will be more unique, right? They have similar characteristics. And then if you have similar characteristics for your own house, you can just use the mean of this subgroup to make your predictions, right? So actually from the whole process, actually from this summary, right, the first table you have, actually you still have the R square. You still have, actually this is also called RMSE, right? And then you have the number of splits. So actually until now I split 8 times. And this AIC is also another indicator for whether this model is good or not. So actually the decision tree, the inside of this decision tree is still making the regressions, but it used the methods to tell you or show you kind of a picture so that you once, for example, once you have the equation in the previous chapters, you plug in the numbers of for example, you plug in the numbers of floors, then you have a prediction. But here you have different groups. For example, if you have floors larger equals to 2 and with another range of gross area, then you can make a kind of accurate predictions, which is enough for you to make the conclusions. Right. So that will be this will be our decision tree. Very straightforward method to make the predictions without generating the equations. But actually inside of this decision tree is also the regression. It will not it just be easier for you to look at the whole picture and then choose your predictions from each subgroup. All right, so now let's just focus on this decision tree, right? So actually this decision tree is just what we generated from the first step, right? So we just split the first time, the second time, the third time. All right, and then after these 3 splits, we find out that our R square is 0.547, right? This RMSE, which is the root MSE, is 66.72%, no, 66.72. And then we have 3 splits, and total number of houses is 5,802 houses in our sample. Right, so that would be our summary. In the end, we have all of the houses divided into 2 subgroups based on the gross area. Right, in the end, we go to the next step. That's this subgroup, the gross area less than 3667, be divided into 2 more subgroups based on the gross area, whether it is less than 2595 or larger equals to 2595. Right, and then after that, another split based on this subgroup, gross area less than 2595, based on what? Based on the floors is less than 2 or larger equals to 2. All right, okay, so now this is the decision tree. Based on the decision tree, let's answer a question. First, all right, if I have a house with gross area is 4,000 square feet and 2 floors, with this decision tree, what is the predicted house price? Any volunteer? $4,000 square feet. Remember, we need to read the decision tree from the top to the bottom. Right, so that means we need to follow the directions, right? So actually we need to, from the first step, right, we have all the houses. It is divided into 2 subgroups with first the gross area less than 3667 to larger equals to 3667. So now which group is our home, is our house belong to? This one, right? But after this point, you do not have any subgroups. Then you can only make the predictions for this group. That means it doesn't matter, or I don't care how many floors you have. Based on this decision tree, the predicted house price will be just this much. Right, so remember, when you read the decision tree, you always read from the top to the bottom, or we read from the root to the leaf. Right, so we call each of the end node, we call end nodes. All right, so we call each of these end nodes as, we also call it as the leaf nodes. Right, so that means you do not have any subgroups after this step. So that means how many leaf nodes? We have 1, right? No more subgroups for this group. Another one, no more subgroups for this group, right? And then we have 2 more leaf nodes. So that means our predictions will based on these 4 leaf nodes. See which one it belongs to, which group it belongs to. and then you can make the predictions. All right, so let's make another prediction. We say, if I have another house for a small one, 2,000 square feet. It is a, let's say, a single-story home. That means what? That means 1 floor. All right, so how you can make the prediction for this house based on this decision tree? Remember, we read this decision tree from this direction, from the root to the leaves, right? So that means from all houses, first, you need to decide which subgroup it belongs to, right? So actually your house has the gross area, which is 2,000 square feet. That means less than 3667. Right? After this step, this subgroup is divided into 2 more subgroups based on less than 2595 or larger equals to 2595. So in this case, it is less than 2595, right? So that means now it belongs to this subgroup, and it's still not the end nodes or leaf nodes yet, right? So then we need to continue to the next one, next step, based on what? Based on the floors. So now you have only 1 floor, so that means your floor will be less than 2, right? So then what will be the prediction for this house? It's 305.809. Got it? All right. Remember to read the decision tree from the top to the bottom. Never choose from the bottom to the top or randomly choose one. All right. So always follow the procedures that the JUMP provides you. All right. Okay. One more question. Just one more question will be okay for today. All right, so since we say we totally have 4 end nodes, that means what? We totally divide the whole, all of these 5,800 houses into actually finally with these 4 subgroups, right? Each subgroup have their own mean house price. Right now, what will be our rank 1 for the house price? What will be, what group of the houses has the most expensive houses? Which one? Um, Garvin, are you there? Garvin.
Yeah, I'm here.
Yep. So what will be your rank 1 house, the most expensive house? What kind of house has the highest house prices?
Would that just be the one with the gross area greater than or equal to 3,667?
Perfect. Good job. Right. So that will be the yellow group, right? The yellow circle group, right? So that means how you can describe this group of houses. That would be the gross area would be larger equals to 3667, right? Do you have the limitation for the number of floors? No, right? So as long as it is larger than 3667, this is the most expensive houses group within this tree decision tree. Right, so next, the second rank. Let's say Olivia,
That would be if the gross area was greater than or equal to 2000, the 2595 one.
Is there any other limitation for this group of house?
There isn't because the floor level is only attached to the gross area that's less than 2595.
Right, so actually for this group, remember you need to read the decision tree from the top to the bottom, right? So actually this group is coming from here, right? So actually your gross area should be first less than 3667, and then within this group, larger equals to 2595. So then the limitation for, or the way to describe this house type, the group, is the gross area should be larger than 2595, but at the same time less than 3667, so that it doesn't belong to this group. Got the idea? All right, okay, so number 3, a little bit challenged. How you can describe the number 3 or rank 3 houses? Say we actually look at their means, right? So the largest mean is 542. Next one is 396. Next one, which is the next expensive house group, will be this one, right? How you can describe it? Remember from the top to the bottom. So that means first, this group actually belongs to this subgroup, right? So that means your gross area first would be less than 3667. And then within this subgroup, another limitation, gross area should also less than 2595. And then within this subgroup, you also need to make sure the floors should be larger equals to 2. But actually, these two are repeated, right? So if the gross area is less than 2595, of course it is less than 3667, right? So then how to describe this house group would be gross area less than 2595 and the floors is larger equals to 2. Right? Of course, the last one, this is another group of this subgroup, right? So that means the GA, the gross area should be less than 2595, but now the floors will be less than 2. So that will be the description about this subgroup. All right, so be sure to read the decision tree from the top to the bottom. This